x squared is equal to y cubed. Let's graph this in both rectangular and polar coordinates. And for polar, we need to first convert. So wherever we have an x, we're going to put in r cosine theta. Wherever we have a y, we're going to put in an r sine theta. Let's get in our squared and our cubes to both pieces. And now we want to get r by itself. And what we want to do is we want to move everything to one side, factor out the r, and then simplify. So we've seen this before in our trig section. 0 equals r cubed sine cubed theta minus r squared cosine squared theta. We can factor out an r squared then. R sine cubed of theta minus cosine squared of theta. We can then set up two equations. R squared is equal to 0, or r sine cubed of theta minus cosine squared of theta is equal to 0. R squared is equal to 0 as part of our graph, just it's the point at the pole. So that doesn't help us at all. Over here, we've got r sine cubed equals cosine squared of theta, and then we'll divide both sides by sine cubed. So you get r is equal to cosine squared theta sine cubed of theta. And we want to confirm, do we have the same thing as x squared is equal to y cubed? So up here, we'll take the cubed root to both sides. So y is equal to the cubed root of x squared is really what we're comparing to cosine squared of theta divided by sine cubed of theta. So starting off, we're in functional mode. So we'll do the cubed root of x squared. Remember, cubed root is under math, and it's option number 4. So the cubed root of x squared. If we look at this, we sort of have this V shape that's curved on both sides. Sort of looks like a little bird flying at us. Now let's convert to polar form, and we'll do the same comparison. Cosine of theta squared divided by sine of theta cubed and sure enough, we get the same picture for that graph as well. So x squared equals y cubed is the same thing as r equals cosine squared of theta divided by sine cubed of theta. Probably wondered over here, couldn't I have just divided both sides by r squared and gotten the r cubed and r squared to cancel out? Yes, you technically can do that, but mathematically that's not something we want to do. When you get into solving equations, remember you start losing solutions, so we don't like canceling on both sides of the equal sign like that. We want to factor out, set equal to 0, and see is there anything that we could work with in terms of this r squared. But if you look at it, yes, in this situation, dividing both sides by r squared would have given us the same answer earlier on.